Level up your AI game, Backpropagation as your guide. Imagine playing a video game for the first time. You're unfamiliar with the controls, the rules are hazy, and your initial attempts are clumsy. But with each game, you learn. You adjust your strategies based on your successes and, more importantly, your mistakes. This process of learning from errors is the key to mastery. In the world of artificial intelligence, this learning process is powered by an algorithm called backpropagation. Backpropagation is the engine that drives many AI applications, from image recognition to natural language processing. It's how AI systems learn from data, identify patterns, and improve their performance over time. Just as a gamer refines their skills through trial and error, backpropagation allows AI to adjust its internal settings to achieve increasingly accurate results. Forward propagation. Taking your best shot at recognizing cats. Let's dive into a specific example. Teaching an AI to recognize cats in pictures. The AI system processes information through a network of interconnected nodes, much like neurons in the brain. This network is organized in layers, with each layer performing a specific task. The first step is feeding the AI an image of a cat. This image, represented as numerical data, travels through the network layer by layer. Each node processes the information, performs calculations, and passes the results to the next layer. This process, called forward propagation, culminates in the final layer producing an output, the AI's best guess about the image. Measuring the misunderstanding error in AI training. Initially, the AI's guess might be far from accurate. It might mistake a fluffy dog for a cat or even a houseplant for that matter. This is where the concept of error comes into play. The difference between the AI's output, its guess, and the desired output, the correct answer, in this case cat, represents the error. This error is a crucial piece of information. It tells us how far off the AI is from the correct answer, and more importantly, guides the learning process. By minimizing this error, we can train the AI to become more accurate in its predictions. Backpropagation. Retracing your steps to improve the game. Now comes the heart of the learning process, backpropagation. Instead of simply discarding the error, we use it to fine-tune the AI's internal settings. Remember those interconnected nodes in the network. Each connection between these nodes has a weight associated with it. These weights determine the strength of the connection and influence the flow of information through the network. Backpropagation works by propagating the error signal back through the network layer by layer. As the error signal travels backward, it adjusts the weights of the connections between the nodes. The goal is to find the optimal set of weights that minimizes the error and leads to more accurate predictions in the future. Gradients. Guiding your AI to higher scores. Imagine you're standing on a hillside and want to reach the valley below. The steepness of the slope at your current location guides you towards the fastest way down. Similarly, in backpropagation, we use gradients to guide the weight adjustments. A gradient is a mathematical concept that tells us the direction and magnitude of change. In the context of AI, the gradient tells us how much and in which direction to adjust each weight to reduce the error most effectively. It's like having a compass that points towards the optimal settings for our AI. The chain rule, a waterfall of learning. Calculating these gradients might seem complex, especially in a network with many layers and connections. This is where the chain rule comes into play. The chain rule is a mathematical tool that allows us to break down complex calculations into smaller, more manageable steps. Think of a waterfall cascading down a series of rocks. The water's final destination is determined by the shape and position of each rock it encounters along the way. Similarly, the chain rule helps us calculate the impact of each weight on the final error by considering its influence on each layer of the network. Gradient descent. Fine-tuning your AI for peak performance. Armed with the gradients, we can now adjust the weights to improve the AI's accuracy. This is where gradient descent comes in. Imagine yourself taking small steps down that hillside, always moving in the direction of the steepest descent. Gradient descent works similarly. It's an iterative process where we repeatedly adjust the weights in the direction indicated by the gradients. With each iteration, we take a step closer to the optimal set of weights that minimizes the error and makes our AI smarter. Repetition is key. Practice makes your AI perfect. Just like a gamer improves with practice, an AI's accuracy improves with each iteration of forward propagation, error calculation, backpropagation, and weight adjustments. This iterative process, repeated thousands or even millions of times, allows the AI to learn from the data and fine-tune its internal settings for optimal performance. The beauty of backpropagation lies in its ability to handle vast amounts of data and complex network architectures. It's a powerful tool that allows AI systems to learn and adapt, constantly improving their performance and expanding their capabilities. Backpropagation in a nutshell. A recap for AI masters. We've journeyed through the fascinating world of backpropagation, the engine behind AI learning. We started with forward propagation, where the AI makes its initial guess. Then we calculated the error, a measure of how far off the AI is from the correct answer. Backpropagation came next, propagating the error back through the network and adjusting the weights of the connections between nodes. Gradients guided these adjustments, pointing us towards the optimal settings. The chain rule simplified the calculation of gradients, breaking down complex computations into manageable steps. Gradient descent, our iterative optimization algorithm, used these gradients to fine-tune the weights and minimize the error. Through repeated iterations, our AI learned from the data, becoming more accurate with each attempt. The future of AI. Keep exploring, keep learning. Backpropagation is a testament to the power of algorithms to mimic and even surpass human learning capabilities. As AI continues to evolve, our understanding of backpropagation and its applications will deepen, leading to even more sophisticated and impactful AI systems. The journey of AI is just beginning. As we continue to explore the vast potential of artificial intelligence, a deep understanding of backpropagation will be crucial. So, keep exploring, keep learning, and who knows what amazing AI-powered future we'll create together.